Hello, this is Mrs. Decker, and in this video I'm going to go over Objective 1.3 on periodic trends. So there are three main trends that you need to understand and be able to use. There are atomic radius, ionization energy, and electronegativity. You do also need to know how to find the number of valence electrons from the periodic table, but you should already know how to do that from 1.2. You do also need to use the trends to predict the properties of an element. So first we're going to review where metals, nonmetals, and metalloids are on the periodic table because that's important for understanding the trends. So metals are elements that like to lose electrons easily, and that's because they have 4 or less valence electrons. So metals are found on the left side of the periodic table. Nonmetals are the elements that prefer to gain electrons, and that's because they have 4 or more valence electrons, and they are found on the right side of the periodic table. And metalloids are the elements that border the stair step except for aluminum. So right along the stair step, write metalloids. So understanding where to find metals, nonmetals, and metalloids will help you better understand the trends of the periodic table. The first trend we want to talk about is the atomic radius. Radius should be a familiar word to you already. You should have heard it from math. And you should remember that the radius is the point from the center of a circle to the outer edge of the circle. So atomic radius is the same idea. It is the distance from the center of the nucleus to the outer edge of the electron cloud. And it is probably the most important trend to understanding the others. So the atomic radius increases as you go down a group, because as you go down a group, you're adding more energy levels for the electrons to fill. So each energy level adds radius to the atom. Most students think that since as we go from left to right across the period and we're adding more electrons and protons, that the radius would grow even more. But that's not what happens. The radius shrinks as you grow across a period. So it is increases from right to left. And that's because as you have more protons, more positive charge, and more electrons, which is more negative charge, they're more attracted to each other. So that pulls the radius in tighter, it pulls the electrons in tighter to itself. So the general trend goes like that. So your biggest atoms are down here, and the smallest atoms are up in the top right-hand corner. So I might give you two elements, say lithium and sodium, and ask you to tell me which one has a bigger radius. The answer would be sodium because it's further down. The radius increases as you go down a group. So that's the type of question that you should be able to answer. The next trend that we're going to talk about is ionization energy. And ionization energy is the energy that is required to remove the most loosely bound electron of an atom to form an ion. Ionization energy is measured in joules and it is always positive. So when we're looking at a group, the ionization energy is going to decrease as you go down a group because the outermost electrons are going to be further away from the nucleus and easier to pull off. So you want to draw an arrow going up because ionization energy increases up a group. It also becomes harder to pull electrons away as you move to the right of the periodic table because there's more protons in the nucleus to hold on to them. So it increases from bottom to top and from left to right. So your general trend is like that. The smallest is down here, and the biggest is up here. So it's important to understand how ionization energy relates to radius. The larger the radius, the easier it's going to be to pull those outer electrons away. So the ionization energy is going to be lower when the radius is larger. Next, we're going to talk about electronegativity. So electronegativity also has to do with the electrons, and it's the measure of an atom's ability to attract electrons to itself. So ionization energy is about being able to remove electrons. Electronegativity is about being able to gain electrons. So the most electronegative element is fluorine, and it has a value of 4.0. The least electronegative element is francium, and it has a value of 0.7. So if we're looking within a group again, the electronegativity increases as you go up a group. That's because it's the nucleus that's attracting the electrons, and the nucleus would be closer the higher up in the group. So it's able to attract them more. Then as we move from left to right across a period, it becomes easier for the atoms to gain electrons because there's more protons in the nucleus. So electronegativity increases as we go to the right as well. So again, your biggest are up here and lowest electronegativities are down here. Now, if you look, the noble gases here is gray, and it's gray for a reason. That's because noble gases already have 8 valence electrons, and they don't want to gain any, and they don't want to lose any. So when we're talking about ionization energy or electronegativity, they're not really being taken into account for because they already have their 8 valence electrons and they're happy like that. So again, a question you would have to answer for this is if I give you 2 elements, say lithium and magnesium, you would have to be able to tell me which one has the larger electronegativity. So that would be magnesium because it is further to the right. We also want to understand how electronegativity relates to radius. So the smaller the radius, the larger the electronegativity. The smaller the atom is, the easier it is for it to attract electrons to itself because that electron would be closer to the nucleus. Okay, so next we want to talk about some properties of the few specific families that we have. So the families demonstrate the same properties as each other because of the periodic law. So when you place elements in order of increasing atomic number, we see regular and repeating patterns of physical and chemical properties. So the first group we're going to talk about is 1A, the alkali metals. Right? So all of the alkali metals have 1 valence electron, and they all share some similar properties. They're all highly reactive, so they're usually found in compounds. They become more reactive as we travel down the periodic table. That's because as you go down the periodic table, that 1 valence electron becomes further away from the nucleus, so it's easier to remove and results in a bigger reaction. All of the alkali metals also react with water, and they are very soft and can usually be cut with a knife. The next group we're going to talk about is 2A, the alkaline earth metals. And they all have 2 valence electrons. They are all shiny and silvery white. They are all somewhat reactive, but not as much as the alkali metals. And they are not found freely in nature. They are usually found as part of a compound. So you won't find calcium usually by itself. It's usually a part of a compound. Next, we'll talk about group 7A, the halogens. So since they are a part of 7A, that means they have 7 valence electrons. They are the most reactive group of the nonmetals because they have 7 valence electrons, so they only need 1 more to get to 8. And they react with most metals to form salts. And the last group we'll talk about will be the noble gases. They're group 8A, so they have 8 valence electrons. And since they have those 8 valence electrons, they don't combine easily with other elements, which makes them very stable. So I hope this helps you understand the periodic trends. As you are working through the practice, let me know if you need help.